Okay, today we're going to go back over characteristics of linear functions. Okay, this is just a complete review of Algebra 1. All right, none of this stuff on this sheet is new. Characteristics of linear functions we've got to know so that we can get to our next topic, which is systems of equations, which is more than one equation. So we have to be able to deal with one before we can deal with more than one, right? So our objective of the day, everybody look at the objective of the day. Today, I will recall the characteristics of linear functions. Okay? We're recalling these. Again, this is all just a review of Algebra 1, but we need it. It would be nice to have it on one sheet of paper in one place. It's actually more than one sheet of paper, but you know what I mean. Okay? So, let's start here. What's the linear parent function? Y equals x, right? Okay? Now, I know that you guys know that I hate I hate pen, but for whatever reason, I have to write in pen so you guys can even read this at all. If I write it in pencil, you can't see it. I don't know why it's doing that. Okay? So I'll apologize right now for writing in pen. Okay? What is the domain of my linear parent function? What are the x values of the linear parent function? Should we graph it first so we can look at it? Okay? Linear parent function goes here. That's my linear parent function, right? Now, are there arrows at the end of my linear parent function? Do I have to draw them? I don't have to, right? Because I know if it's a linear parent function, it goes on both directions. Okay? So, what's my domain? It would be all real numbers, right? All real numbers? That is my set notation, right? How do I write it in interval notation? Do you remember that? Negative infinity to infinity. You remember that? Good. What's my range? How far down does it go? How far up does it go? Same, right? It's still all real numbers. Or negative infinity to infinity. Okay? What's my table look like? Well, if my parent function is y equals x, whatever x is, that's what y is, right? So if x is 2, y is, negative 2, y is negative 2. If x is negative 1, y is negative 1. If x is 0, y is, if x is 1, y is, if x is 2, y is 2. If x is 3, y is 3. What patterns do you observe in the table and graph? Well, we just talked about it, right? Whatever x is, y, that's what y is. That's the patterns we observe in the table. And the graph, we've talked a lot about the patterns in linear parent functions, so we're not going to answer that on the sheet. You can answer it later if you wish. Okay? So let's go over the characteristics now. Because again, our objective today is to recall the characteristics of parent functions, of linear functions. Okay? So there's three different forms of linear equations as far as equations go. Okay? The first one is standard form. ax plus by equals c. That's standard form of a linear equation. Okay? Then there's point slope form. Point slope is y minus y sub 1 equals m times x minus x sub 1. Okay? And last but not least is slope-intercept form. You guys know that. You guys are really good at that. Y equals mx plus b. Okay? What changes are caused by m? Well, what is in m to begin with? What'd you say? The slope, right? That's right. Okay, so what changes are caused by m? Well, let's start here. If m is 1, if m equals 1, then it has the same slope as the parent. Right? Same slope as the parent function, correct? Does that make sense to you? Okay. What happens if m is greater than 0? What kind of line do I have? It's, what do you mean by positive? It's going where from left to right? Up. So what's a word we could use that goes up from left to right? Increasing. Very good. That increases. That line increases. So what happens with if m is less than 0? It decreases. Very good. Now let's get a little pickier. Okay. Oh, do we need to say increases from left to right or decreases from left to right? We said that when we were coming up with these words, but we didn't write it down. Are you okay knowing it's from left to right, or do you need to write it down? You're good? Okay. If you need to write it down, go ahead and write down increases from left to right, decreases from left to right. Okay. What happens if the absolute value of m is greater than 1? Whatever number m is, whether it's positive or negative, if that number is greater than 1. Not necessarily just increasing, because if it's a negative, it's going to be decreasing. But how is it compared to the parent? Yep, it's steeper than the parent. Now, in transformation language, that means it is a vertical what? Stretch. Very good. Okay. So if the absolute value of m is greater than 1, then it's steeper than the parent function. It's a vertical stretch. If m is between 0 and 1, that's not what I meant to say. I'm sorry. -1 and +1. Not counting 0. Okay, so this is a -1. So if m is between -1 and +1, but not counting 0, everybody knows what this means, right? M is not 0. Then what? It's less steep than the parent. And what's that called in transformation language? A vertical compression. Very good. How do you know if it's vertical or horizontal? That's a good question. Okay? With linear functions, we really only ever talk about vertical. Okay? When we get to parabolas, because that's the next thing we do where we talk about transformations, I think that will be very clear at that time. Because I will, knowing that you have that question, I will work hard to make that very clear. Is that a deal? Okay. So what about changes caused by B? First of all, what is B? And don't give me any names of girls in the hall. That's not very nice. Okay? It's the y-intercept, right? So changes caused by B. B is our y-intercept. So if B equals 0, then what? The line goes through the origin, right? What did one of you guys erase that on the board? I think you're having trouble seeing it because of that writing. Thank you very much. Yes, please. There, I can scoot it over a little bit. There we go. Okay. So if B is 0, then the line goes through the origin, right? Now, if the B value is greater than 0, what happens? It doesn't go through the origin. Where does it go? Above the origin, so it is a vertical shift up, right? Okay, so it's a vertical shift up how far? You do. We gave it a name. You do know. What did we call it? We called it B, didn't we? So it goes up B units. Okay? So what happens if b is less than 0? A vertical shift. It is below the origin. That's good. So we know it's a vertical shift down. How far? b units. Any questions about that? Excellent. Let's go to the next page. Is any of this stuff new to you? Or are we doing like our objective states and recalling our characteristics of linear functions? Yes, we are recalling, aren't we? Okay. Now, let's talk specifically about slope again. All right. How do you define slope? First of all, how many ways are there to define slope? 84? Probably not that many, but there's a lot, right? There's a lot. So tell me one of the ways that you define slope. Rise over run. We've said that before in here even, haven't we? So it's steepness. Okay, so steepness. Okay. For the record, I want you to have at least 3 more. And I'll help you out in case you need help. What about this? Rate of change. Very good. What about this? In, I think, Greek, that's a delta. It's a letter. It's a delta. When we use it in math and science, we use it to mean change. Okay? So it's kind of like rise over run, and kind of a mix of rise over run and rate of change. We're saying that the change of the y's, change of the rise, over the change of the x's, or the change of the runs. Okay? One more that I want you to know, it's not really a definition of slope, but it's how we notate slope. What's that? Yeah, M. Okay? So, explain how to find slope from each of these 4 representations. So one of the things that's on that list over there that I did not include in our objective today is being able to go back and forth from different representations. That's one of our TEKs that we have to cover. Okay, we have to be able to go back and forth from a table and a graph, and an equation and a table, and a graph and an equation, all sorts of stuff like that. So we're actually covering more TEKs today than I even put in the objective. So we are clearly amazing. Okay? So if we're looking at a graph, how do we find the slope? We count, right? And you know that because it says. What do we count? Rise over run. If you're given a graph, the easiest way to find the slope is to count it. Okay? If you're given a table, what do you find? Delta y over delta x. Don't get fooled. Okay? It's the change in y's over the change in x's, not the other way around. Okay? What about if we're given 2 points? What do we have to compute? Well, we haven't written this yet, so let me remind you of it, because that's what we're doing today, right? We're recalling our characteristics. You remember what that is? It's a slope formula, right? Okay. What about an equation? How do you find slope? You look. What are you looking for? If it's in y equals mx plus b, we look for the multiplier of what? Of x. It's the multiplier of x. That's where the slope is. But that's only true if it's in slope-intercept form, correct? Okay. So in A, it's right here, -2, right? In B, where is it? It's the 2/3. It's the multiplier of the x. But on C, you have to figure it out a different way, right? We'd have to solve for y. We'd have to get it in slope-intercept form, correct? All right, so let's talk specifically about intercepts. So what is an intercept? Where the line crosses an axis. I took 3 or 4 of y'all's definitions and put it into one. Is that okay? Thank you. So now specifically, just the y-intercept. If we're looking at a graph, determine where the line would cross the y-axis. Very good. Did you say vertical axis? That's good. I'm glad you know that vocabulary word. What if you're looking at a table? What are you looking for in the table? What's true about the y-intercept? What is its x-coordinate? 0. So it's going to be 0 something, and for now we're going to call that something y because it's the y value, right? Does that make sense? Okay. What about if you have the equation y equals mx plus b? It's the b, right? Identify the b. Again, I'm not looking for names of girls in the hall. That's not nice. What about if it's not in slope-intercept form, but if it's any equation? What's true about this? X is 0, so could I plug in an x, could I plug in a 0 for x and then solve for y? Absolutely. Any questions? So then what changes when we're trying to find the x-intercept instead? It has to cross the x-axis. Correct. Y is going to be 0, so x is going to be just the x value, right? What about an equation? Just plug in 0 for y. Solve for x. Very good. You guys are you remembering a lot, or are you using the knowledge that I've just given you to go for the next one? Kind of both. I'm okay with that. Kind of both is good. Okay? Sorry, is everybody done with that? Okay, let's go to the next page then. So here's one of the higher level thinking skills that I'm going to ask you to do. Okay? We're going to complete this chart at the top that says, if you have a slope and intercept, which equation should you use? If you have a slope and a coordinate, which equation should you use? If you have 2 points, which equation should you use? Okay? Part of the higher level thinking skill, though, is being able to go off of this table and not pay attention to it and say, okay, I know I have a slope and a y-intercept, but the easiest way for me to get my equation would be to, and then figure it out. Okay? We have 3 equations, don't we? We have slope-intercept form, we have point-slope form, and we have standard form. And sometimes one of those equations is better to use than the others because of the situation. Okay? So one of the higher level thinking skills, like I said, that I'm going to ask you to do is to determine which of those equations is better to choose in that situation. Okay? In general, if you have a slope and a y-intercept, which equation should you use? Slope-intercept, right? Which is y equals mx plus b. Okay? If you have a slope and a point, which equation is mostly best for you to use? Let me rephrase my question. If you have a point and a slope, which one is best for you to use? Point slope, right? Point slope. But I'm here right now to tell you it's not always the best one to use. And in certain situations, slope-intercept might be better. So what we have to work on in the next couple days when we're covering some of this information is to decide when is it better to use point slope and when is it better to use slope intercept. Because sometimes it'll save us a lot of time depending on which one we choose. Okay? So what about if we have coordinates for 2 points? First, we have to use this, right? First, we have to use the slope formula to find the slope. And then if we have a slope and a point, then probably point-slope form. Again, I'm not going to write it because it's right above there. You can figure that out, yes? And last but not least, if you have a table of data, I'm going to teach you how to make a linear regression in the calculator. If we already have the table of data, that's kind of like having 2 points, right? So we could use the slope formula and then use point slope. But if we already have it, especially if we already have it all in our calculator, why not just let the calculator do the work for us? We know how to do it. It's not like we're letting the calculator have all of our knowledge and all of our skills, right? We've already done it already up here several times. When we have a table is when we're doing the applications. We've already proven our skills. Let's apply it and let the technology help us out. Deal? Okay. Special lines and slopes. Think back to the skier. Do you remember the skier that I drew for you? In my amazing, amazing art skills. The horizontal line has what kind of slope? It was 0 slope, right? So the slope, m, is 0. So which axis is a horizontal line crossing? It's crossing the y-axis, isn't it? Horizontal line goes this way. So like if I'm using this graph down here, a horizontal line is crossing the y-axis, right? So that helps us know that our equations are going to look like y equals 2 or y equals -5, correct? Another way to think about that is if I plug something into slope-intercept form, like right up here, and m is 0, what's left? Only y equals and b, where it crosses the y-axis, correct? Okay. So what about a vertical line? What is its slope? What happened to the skier at the vertical line? Yeah, he was dead. He's undefined. Okay? So what axis is a vertical line crossing? X-axis? So what are my equations going to look like? X equals 3, x equals -1. Vertical lines and horizontal lines are only one variable lines. Okay? Does that make sense? So tell me what you know about parallel lines. Recall your characteristics of linear functions. That's our objective. What do you know about parallel lines and their slopes? They never touch, so they have the same slope. Very good. So if I tell you one of the equations is y equals 2x plus 6, what's the other equation going to look like? Y equals 2x minus 4? 2x plus 17? 2x minus 375,406? Yeah, it doesn't matter what b is as long as the slopes are the same, right? Okay. Any questions about parallel lines? What about perpendicular lines? They cross. How do they cross? At a 90-degree angle. That makes them perpendicular. So what's true about their slopes? They are different. Excellent. They are opposite. Opposite reciprocal slopes. Now, we had a conversation a couple days ago about opposites. In math, what does opposite mean? It just changes the sign, right? Opposite changes the sign. So like 2 and -2. -6 and +6. What does reciprocal mean? Any idea? Okay, I'm going to show you. Okay, what did I do? I stood on my hands, right? Kicked my feet up on the wall. Is that how I normally am? Do I walk around on my hands? No, I walk around on my feet, right? So a reciprocal is flipped upside down, okay? So if I have a number like, let's come over here to the side, just give ourselves some examples. If I have a number like 2/3, what's the reciprocal? The reciprocal is 3/2. What's the opposite reciprocal? -3/2. Okay? These two numbers are opposite reciprocals of each other. Yes? Okay. So what if I told you y equals 3x plus 1 was one of my equations? What is the opposite reciprocal slope of 3?